Hey, welcome to Wagner Academy as we talk about equations of lines here with lesson 3.4 for geometry. We talked about slopes of lines in 3.3 and now that leads us into talking about equations of lines. So we need to know what y-intercept is, what slope-intercept form and point-slope form are by the time we're done, and how to use those things, how to graph equations of lines based on those things. Let's jump right into it. It says if we're given a slope and a y-intercept, or given a slope and a point, or given 2 points, we're going to use different forms or different equations. If you've taken Algebra 1, or sometimes even in pre-algebra you learn about this stuff, this may be a review type video for you. If you haven't taken those courses before, I'm glad you're here. This will be taught in such a way as if you've never seen it before. So if this is a review video but you just don't remember anything about it, this should be good for you. If you remember some stuff but not everything, this should be good for you. If you remember nothing because you never learned it, this should be good for you as well. Slope-intercept form, that's what you use when you're given a slope and a y-intercept. They did a really good job naming that. Nice job naming people, whoever you were. This is in this form. If you've taken Algebra 1, this probably looks familiar. Y equals mx plus b. So why are we doing this in geometry? Well, we're talking about lines in this chapter, parallel and perpendicular lines, and if we graph lines on the coordinate plane, then we're talking about geometry still at the same time as we're talking about algebra. So we're talking about things that apply to both branches of mathematics. This right here, this m value, this is your slope value. And it should make sense that that would come first because the name is slope-intercept form. X and y are the variables. And this value, along with the sign, make sure you include that sign. If that sign is negative, your y-intercept would be negative. This is the y-intercept value. So slope and then intercept, y-intercept. For a slope and a point, we use something called, get ready to have your socks blown off, point slope form. Go get your socks and come back. Pause if you need to go do that. Point slope form is y minus y1 equals m times x minus x1. And so that means, or this is saying that m, this is representing your slope value, just like it was over here. So m didn't change. And then you might be wondering, well, what's this x1 and y1? What's that all about? That's your point. That's the point you were given to start. So your point is x1, comma, y1, your first x coordinate and your first y coordinate. Or in the case that you're given only one point, it's the only x coordinate and y coordinate that you're actually given. And then for 2 points, we actually use point slope form, but first we would have to calculate the slope. If we don't know the slope, we calculate that first and then use point slope form. So that's the idea with this one. So this one we'll just write down what we do. We first calculate the slope. And then we use point slope form. Using one of the points. So if you're given 2 points, you pick one. You pick whichever one you want, call that your x1, y1, and that's the point you can use in point slope form. So let's check these out, put into practice with some graphs. Write an equation in slope-intercept form of the line with slope 1/3 and y-intercept of -2. So this, I'm looking for slope-intercept form, and I'm given a slope and a y-intercept. So that, to put in slope-intercept form, would be very easy. If we're given a slope, and we're given the y-intercept, let's write out what slope-intercept form is again. Y equals mx plus b. And right here, your slope is 1/3. That's going to be put in place of m. Your y-intercept is -2. That value is going to go in place of the positive b. So this becomes y equals 1/3 x plus b. And notice that I wrote the fraction straight up and down. Please do that yourself, so that this is just a little side note. Don't write this down. But if you write it like this, something like 1/3 x. I can't really tell if you mean 1/3 times x or if you mean 1/3x. Those are two different things. So please write it straight up and down with the x bigger in the middle of that there. So this is 1/3 x plus b. Plus b becomes, boy, this isn't right. What should be in place of that? We already said it. It's going to be -2. So please put -2 there instead. My fault on that one. So we've got -2 is the y-intercept. So that means it crosses this y-axis. And with my notes here, we can always assume, unless I tell you otherwise, that this would just be the x-axis and y-axis. So this is -2. And then you've got 1/3 x. So this is a positive slope. This value is positive. So go back to what we were talking about with Super Mario Brothers, the original. If you're going to run uphill, you're advancing in the level as we move left to right. Here, running uphill, that's a positive slope. If you're advancing in the level and you're moving downhill, that's a negative slope. So this is a positive slope. We're going to be running uphill as we move left to right. Up 1, right 3. We'd have a point right there. Another up 1, right 3, and we would have a point, looks like off the graph a little bit, but it would be right there. If you went down 1, these points have to remain collinear. So you'd go down 1, left 3. That would be like -1 over -3. Same thing as +1 over +3 after you simplify those fractions. So let's draw in the line. The line would be like that on the graph. And that'll do it for that one. Example 2. Write an equation in point slope form now, okay, of the line whose slope is -3. So they give me the slope, it's -3, and then they give me a point. So if they give me a point and they give me a slope, it's very easy to put it into point slope form. So we're going to write this general form out first. Y minus y1 equals m times x minus x1. And I'm going to plug in the values that I'm given. I'm told that m is -3. I'm told that -2 and 4 is a point. So I plug that in for x1 and y1. So it looks like this becomes y minus y1 equals -3 times x minus, and sorry, this, boy, y minus what? What did I mean to put in there? 4. So y minus 4 equals -3 times x minus x2. Sorry about that little foible. Hopefully you're writing in pencil as always, so that you can fix things as needed. Now this I could write as y minus 4 equals -3 times x plus 2. Minus a negative can become a positive. In point slope form, is this in point slope form? Sure is. Negative, negative becomes a positive. I can leave it like that if I'm told that it's needing to be in point slope form. I want to leave it like that. So if you were given something in point slope form already and had to figure out what the slope and the coordinate was based on that, look at that value. That's your slope. Look at the values here and here. The form has a minus sign, so it would be +4 for your y value and -2 for your x value, since the form has the minus sign in it. But if we were to graph this, if we had to do that, -2 up 4, you'd have a point right here. So that'd be -2, 4. And then your slope is -3. That's like -3 over 1. You're going downhill as you move left to right. It's going to be pretty steeply sloped. So down 3, right 1, down 3, right 1. That pattern would continue. I'm drawing more points in than I really need to, but just showing you that that pattern continues there. So this would be that line graphed. Now moving on to example 3. Example 3, write an equation in slope-intercept form for the line shown on the graph. So this time I give you a line. We could use rise over run to calculate the slope since it's graphed. I want to show you how you would do that if it wasn't graphed. This is the approach that I would take instead. So this is negative 4, negative 3. And this point right here is 2, 1. So algebraically, we could calculate the slope of this line using y2 minus y1 over x2 minus x1. So I'm going to call the leftmost point my first x and y coordinate. I'll call the right point my second x and y coordinate. And then based on that, I've got y2 is 1 minus y1 is negative 3. I have that over 2 minus negative 4, x2 minus x1. This would become 1 plus 3, which is 4. This would become 2 plus 4, which is 6. We could simplify that to 2 over 3. So if they just gave you points and didn't give you the graph, I would definitely go about it this way. That's the faster way to do it. If they give you the graph, could you actually just look at the graph? Should you do that? I would say yes. So I showed you, though, if they didn't give you the graph, do the algebraic way. So now we calculated the slope. Basically, this is the third option here. We're given 2 points. We can tell where those 2 points are on the graph. Now we're going to use point slope form using one of the points. So I'm going to use this point. Could I use this point instead if I wanted to? Sure. But I'm going to use this point for now. So I've got the form, my general form, y minus y1 equals m times x minus x1. This right here is your m value. This is your slope value. So that's going to go in right there, and your x1, y1 will go in here and here. So let's see what we got. We've got y minus negative 3 equals 2/3 times x minus negative 4. This one we're supposed to write in slope-intercept form. So I could simplify this, change the minus negatives to positives, but I can't stop there this time because I need to have this in slope-intercept form. I need y by itself equals something x and something else. So let's distribute this 2/3 to both parts there and there. I'm left with y plus 3 equals 2/3 x plus, and if you don't remember how to multiply fractions, you can put that over 1. This would be 2 times 4 on the top, 8 over 3 times 1 on the bottom, 3. You can think of it like that. So I need y by itself, so I still need to subtract 3. I need to move 3 to the other side of the equation. This would cancel out here and here. That would leave me with y equals 2/3 x. And then positive 8/3 minus 3, we would have to have common denominators to be able to combine those together. So an integer value, I can make a fraction. In this case, this is like 3 over 1. You can think of it like that. I could multiply by 3 over 3. And that would give me 9 over 3, but negative. So this is the same as negative 9 over 3, this value right here. So if you need some work on your fractions, make sure you practice, review those things. We're going to have to use fractions here in this lesson and as we continue through geometry and math. So 8/3 minus 9/3, that's the same thing as 8/3 minus 3. That would be negative 1/3. And it looks like this would be slope-intercept form. We'll have y equals something x and then something else after that. Let's see if that matches, jives with what I see here in the picture. So when I look at this picture, had I been able to just look at the y-intercept and clearly say, oh, that's at 0 or that's at 1, then I really wouldn't have had to have done all this. However, it wasn't clear just looking at the picture where that was exactly. So does it look like it could be at negative 1/3, a little less than halfway from 0 to negative 1? I would say definitely. It looks like that could be a valid y-intercept. And then 2/3, are you going up 2, right 3? Up 2, right 3? Sure are. So that works out. This checks out with the graph. Let's check out example 4 now. So example 4 says to write an equation in slope-intercept form for a line containing 0, 3 that is perpendicular to the line y equals x minus 2. So this line, the perpendicular line, I'm going to do this in blue. So I'm going to circle that in blue. That's your normal color. And then If you have a second different color, I think it would be useful here. I'm going to use green to do on the graph over here the perpendicular line. So I know that this line right here would have a slope equal to, if there's no number written in front of a variable, we assume there's an invisible 1 there. So the slope is equal to 1, or just think of that as 1 over 1. That's a way to think about it that helps graph it. So up 1 over 1. The y-intercept is this value. It's -2 for the green line, the initial line that the blue line will be perpendicular to. So this graph would be right here, is where I would start, -2 for the y-intercept. And from there, the slope is 1. So go up 1, right 1, up 1, right 1, up 1, right 1, and so on. Do I have to draw all these points? No, but just trying to emphasize the point that the pattern continues going this way. If you go down 1 and left 1, that's like -1 over -1, which is the same as +1. And you simplify that. So you got all those points. Let's draw in that line. If you have a straight edge, good to use that here. Make that a little straighter there, or a little more on the crosshairs there. That's a little better. And I'll put my arrowheads there. So I have this other line that's going to be perpendicular to this line. So at 90 degrees, coming in at a right angle, but it has to contain this point as well. So it has to be containing 0, 3. And that's going to be my blue, but I switched that not yet. Let's see, there we go. So my blue line, so it looks like it's going to come down kind of like this, right about here, but let's calculate. I'm not exactly sure where those are going to be hitting exactly at this point. Yes, that was redundant. I said exactly twice. Didn't need to do that. Perpendicular lines. The upside down T is the symbol for perpendicular. You can use that as shorthand. So perpendicular lines, do you remember from our previous lesson from 3.3? They have what kinds of slopes? If you said opposite reciprocal slopes, you would be correct. So they have opposite reciprocal slopes. So that means the slope of the perpendicular line, so the perpendicular line has slope of, it's going to be this flipped, so 1 over 1 is still 1 over 1, but it's also the opposite of that, so it's negative. So it's -1 over 1, which is just the same thing as saying -1. So this is right here, this is your M value for the green, or not for the green line, for the blue line, excuse me. So therefore we can say the equation for a perpendicular line containing 0, 3 is going to be this. And this is your x1, y1. This is your x coordinate and y coordinate given for the blue line. We've got this is our M, our slope. We've got a coordinate. So I see a point, I see a slope. Let's use point slope form. So I have y minus y1 equals m times x minus x1. That would become, after I plug things in, that would become y minus 3 equals -1 times x minus 0 in this case. X minus 0 would just be x, so this could be written as -1 times x. I don't really have to distribute the -1 to the 0, because that would still be 0. And then from there, I'm trying to write this in slope-intercept form, so I need y by itself. I would add 3 to both sides, and that should do it for me. This would cancel. I've got y then by itself equals -1x. We can just write as -x, and we should just write it like that in the end. And then plus 3. We added 3 to both sides. This is our equation for the blue line. So here the slope in this, to help us graph it, let's write that out. The slope would be, we expected it to be -1, or we should have it as -1. And the y-intercept is 3. And we already knew it was 3 because that was actually a point right there on the line. But this would have to be true about this blue line. So the blue line, we have a slope of -1. That's -1 over 1. -1 over 1. That pattern continues going this way. And if you went up 1, you'd have to go left 1 instead. So let's connect all those points with a blue line. Yep, got it. So blue. There is my perpendicular line containing the point 0.03 that is perpendicular to the given line in green there. So this would be perpendicular, this angle right here would be perpendicular there and there. And a final example where we use this idea of writing equations, using equations to model real life situations. We can do that here. We'll do that here in example 5. So suppose the El Paso County Fair charges $10 for admission plus $1.50 for every carnival game you play. Let's write an equation to represent your total cost C for the games played. So your total cost C at the El Paso County Fair would be, well, you're getting, as you walk into the gate here, you're going to get charged $10 right off the bat. So it's $10 plus however many games you play times $1.50. So that would be plus 1.50 times G. You could say this is the same thing as, if you were to write it in a slope-intercept form type way, C is like your Y and G is like your X. You could write 1.5 instead of 1.50. And so this would be an equivalent way to write the same equation. But I'm going to use this one instead of that one. They're both representing the same thing, so it doesn't really make a difference. And I chose to leave this as 1.50 because I'm thinking about money, so I think it makes sense to do that, but you could write it as 1.5. So now if the Douglas County Fair charges $15 for admission plus $1.25 for every game you play, which fair would be less expensive to attend if you intend to play, wow, 25 games? So maybe you're going to play this game, and this game is much harder than it looks. It looks like, oh yeah, it'd be easy to knock all those down, but you have to really focus on knocking all 4 of these down here at the bottom. That's the only way you're going to ever win. The dart game, darts just slip right off the balloons. But maybe, just maybe, you can be a lucky winner like this little kid was, and like I was one time at a carnival game. I was so happy that I won a giant minion. Oh yeah! In the words of Vector, very excited. Great movies, the Despicable Me movies. Wholesome, clean family fun. Oh yeah. If the Douglas County Fair charges $15 for admission, all right, so let's go back to the problem. I'll stop talking about Despicable Me. El Paso was 10. The cost was 10 plus $1.50 times the number of games. And we're going to assume you're playing 25 games. And this would be 10 plus, and multiplying that out would be $37.50. So that altogether, it's a lot to play for a bunch of carnival games, I think, but it would be $47.50 at the El Paso County Fair that you're spending. If you go to the Douglas County Fair, we don't have this equation yet, but I think it's pretty easy to come up with. The cost would be, well, they charge you $15 as you walk in. So 15 plus $1.25 for every game you play. So plus 125 times the number of games in this case, again, is 25. This would be 15 plus, well, what do you think? They charged you more initially, but will the less per game cost make up for it? In this case, if you played 25 games, it does. So this is $46.25. So if the fares are maybe the same distance away, just as good one versus the other, you may want to consider going to the Douglas County Fair over the El Paso County Fair to save yourself $1.25. So this one, in this case, Douglas is less expensive . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . by $1.25. So there are definitely useful things with the things we're learning here. This is an example of a useful situation to apply the things that we're learning here with. My good friend back in Michigan, he's a supply chain analyst for a pretty big company, and he gets paid to do things like this, but just on a much larger scale with more difficult types of problems. But he helps save the company tens, even hundreds of thousands of dollars a year, because he helps them to become more efficient. He helps them to figure out whether something is less expensive to do this way versus this way. Does a great job at it, and he gets paid well because of it. So that does it for this lesson. Go win yourself a minion at the Douglas County Fair because it's cheaper than the El Paso County Fair. No, I don't really know if it is. I just made those numbers up. But make sure you know that slope-intercept form is y equals mx plus b. Point slope form is y minus y1 equals m times x, quantity x minus x1. Make sure you know how to use those. Make sure you know how to go back and forth between those and how to graph those by the time we're all done here. Go back and review as needed. And as always, have a great day, and I will see you later for our next lesson.